Welcome to Fluids Final Review. We're going to be going over question number 16. Let me share my screen so you can see it. Okay, let's read it. A hydraulic jump occurred to connect a shallow with a deeper flow in figure 1. Channel width is 1 foot. Flow depth before the jump, y1 equals 0.6, and after the jump is y2 equals 2 feet. Determine the flow velocity before the jump, v1, and after the jump, v2. Friction force of the channel at the bottom is neglected. We're given our water values. All right, and this is what our control volume. So big hit here, we're given a control volume. That means we probably should be using momentum. Other things to note, there's force on the left, force on the right, and tau from the wall is 0. All right, so let's get solving. Let me stop sharing so you can see the board. All right, first let's write down what we know, right? So what are we given? We're given that W, the width of the channel is 1 foot. That means whenever we have an area, we're just going to neglect W. Essentially, because it's 1, right? What else are we given? We're given that y1 is 0.6. So on my left side of my figure, y1 equals 0.6 feet. So that's good. Everything's been given in feet so far, so no conversions yet. y2 equals 2.0 feet. So we're going from here to here. We're getting deeper, so our y is bigger. And what do we want to solve for? We want to solve for v1 and v2. In that control volume, because we were given the control volume, that means we should probably use the momentum equations. So let's copy those down right now. Of fx equals m bx out minus m bx in. All right. So now we need to know what are our forces, what is the mass going in, out, and what is the velocity going in and out. So let's make this a little bit more specific to what our problem is. Instead of, it is in the x direction, but we have no y value, so we're only solving in the x direction. So going out is going to be our 2, going in is going to be our 1, so let's properly label those. So first let's see, what does m equal to? Based on our equations, we know that m is equal to rho v a. You see where that a comes in? And let's properly label that. 2. Okay, so now it's properly labeled, everything's written down. So we know the force, when we look back at our figure, let's pull up that figure again. When you look at our figure, we've got F1 coming in, going to the right, and F2 coming in, going to the left. That's very important. It's also important to label where our x and y is. So let's just assume that x to the right is positive, y up is positive. So that means that F1 is positive and F2 is negative. We know that M2 is equal to rho V2 A2 times V2 minus rho V1 A1 V1. Okay. So now what we need to question is, what is our F1 and F2? The force of F1 and the force of F2 are going to be pressure forces. So the way that we can solve for those is we can do gamma 1 but there's something wrong here. So let's fix that real quick. So let's fix it. So gamma y is going to be the force of the pressure, but we also need the location in there. So the location is going to be 1/2 of y. So we're going to add in 1/2 y squared, 1/2 y. The reason it's 1/2 of y is because it's the centroid. So that's why. And let's simplify that a little bit more. Rho v2 squared a2 minus rho v1 squared a1. Okay, so that's looking really good. We know we want to solve for v2 and we want to solve for v1. We know what a1 is, we know what a2 is, we know what rho is. We know what y1 and y2 are, and we know what gamma is. So let's move all of the knowns over to one side of the equation, all the unknowns to the other side. v2 minus v1 pull this over. Something that looks familiar here is A2 times V2. That is a Q value. Okay, so we see that we can apply the Q values in here because, so let's apply those Q values. So Q1 equals Q2, V1, A1 equals V2, A2. Solve for V1 equals V2, A2 over A1. Let's just do a quick little simplification, just to make this easier to look at. We know that W, which is our width of our flow, is going to be 1. So A2 equals Y2 times 1. So A2 equals 1, Y2, and A1 equals Y1. So let's plug that in into this equation up here. So let's plug that all in here. So we're gonna do, and we're gonna plug in our values that we got from the Q. So 1/2 gamma, y1 squared, squared. Actually, I'm gonna write this to save space. Equals. So A1 is actually gonna be y1. V1 is gonna be V2, A y2 over y1 squared minus v2 y. Okay. So based on simplification, we're going to pull out that v2. And then we're going to solve for our v2. If we do that correctly, I'm not going to do it by hand, but we should get, once we do all of the algebra and plugging in, we should get v2 equals 3, 5, 3, 4. And v1, if we look at the equation that we had here, v1 equals v2 times y2 over y1, then v1 should equal 11.81 feet per second, feet per second. And that's how you solve that problem. Thanks for watching.